For this example, we are going to do the prime factorization of 105. So we're going to break down 105 into all the prime factors. And for this, it's only 2, 3, 5, and 7. However, there are many more other prime numbers. Now, we need to fill in the powers, which are really exponents. So that's another word for powers. So we're going to wonder, is this 2 to the third times 3 to the first times 5 to the 0 maybe times 7? And the reason why we have 0 is because anything to the 0 power is 1. So that base 5 would go away. And you would do 5 to the 0 on your calculator, you would get 1. And you can take anything to that 0 power. So negative a million or negative 56 to the 0 power is still just 1. It would be worthwhile to write down these prime numbers, which are the numbers 1 through 30 that are prime. So they're only divisible by 1 in itself. So just 1 times 2 is 2, or 1 times 11 is 11, versus 18 being a composite number because it's not just 1 times 18, it's also 2 times 9, or 6 times 3. And all even numbers are composite. All odd numbers are not. 15 is odd, but however, 3 times 5, 3 and 5 are also factors, as well as 1 times 15. So 1 and 15 are factors, as well as 3 and 5. So 15 is composite, but these are the odd numbers plus the one even number that are prime. So we need to know which prime numbers multiply to this 105. Instead of playing the guess and check game, 3 times what is 105, let's take 105 and divide by a prime number to find the other factor. So I'm going to take 105. I notice it ends in a 5, so I'm going to divide by 5 first. And 105 divided by 5 is 21. So that means 5 and 21 are factors of 105. Now 5 is prime, so I'm going to circle that just to know that one's done. It's on my list here. But 21 is not prime. I'm going to do now 21 divided by another prime number. And I could do 2, but that would be a waste of time because it's not even. So let's try dividing by 3. And 3 times 7 is 9. So I know that I can break this down to 3 times 7. And 3 is prime and 7 is prime. So 105 is actually done right now. It's 3 times 5 times 7. So no matter how you multiply these prime numbers, you'll always get to 105, and there's no other factors that are prime that multiply to 105. So now we have to enter the powers or exponents correctly on Mobius. Now there is no base 2. So since there's not a 2, we're going to use a 0 power because 2 to the 0 is 1, and 1 times 3 times 5 times 7 is still that 105. So 2 to the 0 is that one. And then we'd only have one 3. If we had two 3s, it would be 3 times 3, or 3 squared. But in our case, it's just 3 to the first. And we have 5 to the first and 7 to the first. Hit how did I do? It's going to work out. As a side note, if I would have done prime factorization to 300, I would have gotten 2 times 2 times 3 times 5 times 5. Well, that 2 times 2 would be the base 2 times. And that 3 would be the base 1 time. 5 times 5 would be the base 2 times. And since I didn't have a 7, it'd be 7 to the 0, which really has a value of 1. And anything times 1 is itself. So here's another example of what we would do if the number had more than one factor. Prime factorization comes in very handy when it comes to greatest common factors. Instead of dividing 180 by 1 and getting 180, and 2 getting 90, and the list goes on. Divide by 3, maybe it works, and it does. We get 60. Divide by 4, it works. Divide by 5, it works. Divide by 6, you get a decimal. Well, here's all the factors of 180, and you can go ahead and hit pause and see if you can get them all correctly. Who knows? Maybe I even made a mistake. 18, 20, 36. There's so many factors. And then 324, same thing. divide by 1, divide by 2, divide by 3. You're going to get all these factors. 324, divide by 2, you get 162, divide by 3, you get 108. I'm going to run out of space here again. So I'm just going to list them all out. It does take time to divide and figure them out. So we could do this, 54, 81, and I think that's all I had there. And then you look for the greatest common factor. What factor do they have in common that's the biggest? So I don't see a 324 or 162 or 108. I don't see an 81 of 180. Don't see a 54, 36. Oh, I see a 36 right here. So I'm guessing the answer is 36, but that takes a lot of time. Instead of listing out all the factors and finding the greatest one they have in common, let's break down each number, 180, 324, and let's put the factors they have in common, because this, folks, is the greatest common factor. Now, if you did this, whatever they have in common would go here, and then if you multiply everything in the end, that would be the least common multiple, which is that common denominator idea, but that's a different time, different lesson. Let's take 180 and break it down. Now, it may seem like a lot of work, but trust me, it's a lot less than what I just showed you. So I'm going to start dividing. Divide by anything that you think will work. So some of you might divide by 2 first, that's okay. Some of you might divide by 5 first. Some of you might break it down to 18 and 10, and where it's not a prime number. That's okay. Just be careful that 18 is not done. It's not on our list. So if I take 18 and divide by 2, I get 9. 2 is prime. 9 divided by 3 is 3. So 3 times 3 is 9. And 10 is not prime. That's 2 times 5. So 180 is 2 times 2 times 3 times 3 times 5, or 2 squared times 3 squared times 5. Throwing that out there. All right, let's do the same thing for 324. Why don't you hit pause and try it yourself? So 324, grab my calculator. I'm going to divide by 2 because I know it's even. And I get 162. I'm going to divide by 2 again. 2 is prime, and 162 is even. All right, 81. 81 divided by 3 or 9. Ooh, 81 is 9 times 9. 9's not prime, though. I can break that down to 3 times 3, and 9 is also 3 times 3 for that factor. So 324 is 2 times 2 times 3 times 3 times 3 times 3, or 2 squared times 3 to the 4th. Let's find which factors they have in common. So they have a 2 in common, so they each have a 2 for a factor. They have another 2 for a factor. They also have another 3, so times 3. They have another pair times 3. Wow, 180 only has a 5 factor left over, and 324 has a 3 times 3 factor left over. So the greatest common factor is what they have in common there, which is 2 times 2 times 3 times 3, or 2 squared times 3 squared, and that's 4 times 9, so that's 36. And that's what we got earlier. But this is a more organized way, and it does seem like a lot, but the more practice you do, you will get better. Let's take a moment just to look at the Venn diagram here. 180 is 5 times 2 times 2 times 3, and we could have written that as 5 times that 36 that they have in common. And then 324, that is really 2 times 2 times 3 times 3, and then times itself there, 3 times 3. So the inside is 36. We're left with 3 times 3, which is 9. So 5 times 36 here is 180, and 9 times 36 is 324. So there's ways to kind of look at that as well to make sure you're correct. The greatest common factor is what's on the inside, and the least common multiple would be all of that multiplied together. You could start your homework, but if you'd like another example, this is from your homework anyway. 275, I'm going to find the greatest common factor by finding all the factors that they have in common and multiplying them together. So 275, I'm going to divide by 5 because it ends in a 5 here. And 5 times 55 is 275. Well, 55 is not prime. I'm going to divide by 5 again, and I get 5 times 11. So there's my product, my prime factorization, 5 times 5 times 11. Now 440. Ooh, I see that ends in a 0. I'm going to do 44 times 10 for the heck of it. 44 is 4 times 11, or you can take 44, divide by 4, you'll get 11. 4 is not prime, that's 2 times 2. 11 is prime here. 10 we're not done with, that's 2 times 5. All right, so I have a 2 times 2 times 2 times 5 times 11. That gives us 440. All right, let's set up our Venn diagram and find out what factors they have in common. So I see a 5 in both of them. And I also see an 11. So that's 5 times 11, because this is factors, not adding or anything like that. So 5 times 11. 275 still has a 5 left over, not shared with the 440. And the 440 has a 2 times 2 times 2. All right, so if I really simplified this Venn diagram, it'd be a 5 here. 55 is the greatest common factor because that's 5 times 11. And 2 times 2 times 2 is not 6, it's 8. But anyway, we needed the greatest common factor, which would be 55. Just throwing it out there that if you multiplied all 3 of those numbers together, it'd be the least common multiple. And I just realized also that's in the wrong spot. So the greatest common factor of letter B is 55. Good luck with your homework and break down those factor trees. The more you do, the quicker you will get at them.